And considering all the numbers that are out there, there have been different systems that have been slowly, I guess, emerged over time when trying to describe what's happening. And so we'll just quickly kind of go through some of these here with you. Natural numbers, those are numbers that consider them counting numbers. So 1, 2, 3, etc. So they're going up by 1 every time, 100, 101. No decimals, no fractions, and the first and lowest natural number is 1. Whole numbers is the set of natural numbers, but we just add one more thing. We add a 0. So we have 0, 1, 2, 3, 4, etc. all the way on forever and ever. Those are the whole numbers. The next set up. Now, if you took all the whole numbers and then took all the negative whole numbers, you would have the set of integers. So they go from negative infinity as counting negative integers, negative 3, negative 2, negative 1, 0, 1, 2, 3, etc., carrying on forever that direction. All right. And then rational numbers includes everything between, I'm not going to do a bracket for that one, any number that can be represented by the ratio or by a fraction of 2 integers. All right, so that's a positive number, a negative number, but as long as it can be represented by 2 integers, it's a rational number. First one there, this 1/3, that's a rational number. 0.7 repeating is a rational number. It's actually 7/9. 0.765, just right there by itself. Doesn't repeat, just ends 10 to the negative 7th, so that'd be 1 over a 1 with 7 zeros. All of these are fractions or could be written as fractions. Technically, we also have, 2. 2 is also a rational number because it can be represented by a 2 over 1. Now, irrational numbers are numbers that cannot, so it's kind of defined as the opposite, cannot be rewritten and created and made by the ratio of 2 integers. So there we're talking about numbers like square root of 2. It's not a repeating fraction, cannot be made into a fraction, or a repeating decimal cannot be made into a fraction to represent square root of 2. You've got numbers like pi. Square roots are really the biggest place you're going to see irrational numbers showing up. Pi and e, the number e, we'll get to that later when we're talking about natural logarithms. Those are the two most famous, and now subset of irrational numbers. These are actually called transcendental numbers. So all transcendental numbers are irrational, but not all irrational are transcendental. So this is irrational, but not transcendental. And then lastly, have you ever learned how to convert a repeating decimal into a fraction? If not, we're going to do it here. What we're going to do next on this left-hand side, if you ever have a repeating decimal, you look and say, well, how many decimal places before it repeats? So in this case, it's 1. So it's 1 place. So we're going to multiply it by a 1 with 1 0. So basically 10. So if I multiply both sides by 10, I will get 10x, and that will equal 3.3 repeating. All right. So again, just multiply both sides by 10x. We're then going to, and actually let me do it the other way around. I'll rewrite then underneath it x equals 0.3 repeating. And then what I'm going to do is I'm going to subtract. 10x minus x is 9x. 3.333 repeating minus 0.333 repeating is 3. And then to solve for x, I'm going to divide both sides by 9, leaving me with x equals 3/9, which I reduce is 1/3. All right, on the right-hand side there, the one in blue, I see is, okay, that's y equals 0.23. So I see that there's 2 decimal places before it starts to repeat. So I'm going to multiply everything, because whatever you do to one side, you do to the other side, by a 1 with 2 zeros. That is, I'm going to multiply it by 100. So I'll have 100y equals 23.23 repeating. I have the original, y equals 0.23. Here, let me move that over, just so they line up nicer. 23 repeating. Going to subtract, left with 99y equals 23. Y equals 23 over 99. 23 is prime, so that cannot reduce. So this is how you would fractionally represent a repeating decimal. And all repeating decimals are rational. That's how I know it. And there's your proof on how you can find it if you have any kind of a repeating decimal. Best of luck.